Welcome everyone to another explainer. Look, if you spent any time in a security operations center, you know the absolute pain of a bloated, traditional SIEM. It's like trying to find a needle in a haystack of, well, other slightly different needles. Endless maintenance, heavy infrastructure, and just overwhelming alert noise. Today we're mastering the transition to a streamlined cloud-native model, Microsoft Sentinel.
Okay, let's dive right into this. Are you still paying an absolute fortune to ingest every single log, only to get completely flooded with false positives? That is alert fatigue at its worst. But it really doesn't have to be this way. Today, we are going on a data journey. We're going to follow a piece of security telemetry from its raw, noisy origin all the way down the funnel to a tuned, high-fidelity alert.
Here's our roadmap for today. We're looking at 1. Cloud-native SIEM transition. 2. Telemetry lifecycle management. 3. High-fidelity event correlation. 4. Detection engineering and tuning. And finally, 5. The modern Sentinel SOC. Let's get going.
Section 1. Cloud-native SIEM transition, building the foundation.
Moving right along to Section 2. Telemetry lifecycle management, filtering at the source.
Now, moving to Sentinel isn't just a simple software swap. It really demands a fundamental shift in how we handle our data. The core challenge at the top of our data funnel is balancing total visibility with ingestion costs. And it all begins with your collection method. For cloud-to-cloud, service-to-service integrations, you absolutely want agentless collection. For instance, SAP actually migrated to an agentless data connector specifically to shrink their infrastructure footprint. It's a real game changer. On the flip side, you'll still use agent-based collection, specifically deploying the Azure Monitor Agent, or AMA, for your Windows and Linux VMs, Syslog, and CEF data.
But of course, before that data even hits your Sentinel workspace, it needs to be locked down tight. Whether you're pulling from on-prem servers or moving data across cloud, secure ingestion is absolutely non-negotiable. Using TLS encrypted Syslog is the gold standard here. Honestly, it's a fundamental step you literally cannot skip.
Now, what's really interesting about this slide is how Sentinel handles pre-filtering. Back in the day, we'd rely on a dedicated heavy forwarder server taking up rack space. Sentinel replaces all of that with data collection rules, or DCRs. Think of DCRs as the bouncer at the door of your database. You basically write KQL to perform ingestion-time transformations, dropping those incredibly noisy, useless fields before they ever get stored in the workspace. And the best part? This directly slashes your licensed ingestion costs. So yeah, pretty crucial.
Once that data is filtered, we optimize costs using Sentinel's tiered storage. You're going to place your primary, high-value security logs right in the analytics tier for real-time monitoring. But what about those massive, highly verbose logs you just need for compliance, like NetFlow data? Well, you route those into the data lake tier. It gives you cost-effective, long-term retention. Basically, it keeps your fast data fast and your cheap data, well, affordable.
Okay, Section 3. High-fidelity event correlation, connecting the dots.
So we're in the middle of our funnel now. How do we actually make sense of this massive data pool? The answer is stateful relationship tracking. By using KQL operators like join and summarize, you can track relationships across completely disparate streams. For example, you can join a user's VPN logs with their identity info, and then link that over to their Azure activity logs. All of a sudden, you're tracking a specific anomalous VPN session directly to suspicious database queries that happen within 24 hours of that user's creation. You're finally connecting the dots.
And this brilliantly illustrates the next point. You don't actually have to write manual KQL queries for everything. By enabling the Fusion correlation engine, Sentinel puts scalable machine learning to work in the background. It takes multiple low-fidelity alerts, say a slightly suspicious login followed closely by a mass file deletion, and automatically correlates them. Instead of blasting you with 5 noisy alerts, Fusion hands your analyst a single high-fidelity incident.
To make stateful investigations even faster, Sentinel utilizes the UEBA behaviors layer. Its entire job is to take those fragmented, noisy logs and transform them into structured, natural language summaries. It basically answers one simple question: who did what to whom? It gives your analysts immediate context without forcing them to sit there and manually decipher raw log syntax.
Moving on to Section 4, Detection Engineering and Tuning, Maximizing the Signal.
All right, we're at the bottom of our funnel now. To make sure human analysts only spend time on what matters, the very first step is understanding your blind spots. Sentinel features a built-in MITRE ATTN-CK page, which is fantastic. It allows you to visually map every single analytics rule and hunting query against known threat frameworks. It immediately shows you if, say, you have incredible coverage for initial access, but absolutely zero for exfiltration. It ensures your SOC is monitoring the entire attack chain.
But even with great coverage, you still have to continuously refine your logic. Sentinel gives you two really powerful tools to keep things sharp. First up, the Tuning Insights pane actively watches how your analysts are closing incidents. If a specific service account is constantly triggering alerts that get closed out as false positive, it flags that highly correlated entity and actually recommends excluding it. Super helpful. Second, you've got the SOC optimization dashboard. This uses AI to give you proactive recommendations for MITRE tags or to highlight critical business risk coverage gaps that you really need to address.
So the crucial point here is that you also have to manage the flow of alerts using rules. Summary rules are all about query performance. They take massive verbose datasets and aggregate them into high-level summarized tables so your queries run lightning fast. Automation rules, on the other hand, well, they're about signal clarity. If a weekly server maintenance window always triggers a false alarm, you use an automation rule to instantly close it as a known good activity. That keeps your SOC's KPIs, like your false positive ratios, completely accurate.
And finally, Section 5, the modern Sentinel SOC, ready for action.
Just take a second and think about the journey we just walked through. We took raw, noisy telemetry, filtered it right at the source, stored it smartly in tiers, correlated it with machine learning, and tuned it all against MITRE frameworks. So I'll leave you with this question. Is your SOC actively hunting real threats, or are you just struggling to manage infrastructure and false positives? Because this cloud-native model isn't just about saving money, it's about empowering your team to actually do security. Thanks for joining me on this explainer, and keep learning out there.